Hi, in this video we'll be taking a look at the ODROID XU4. It's an 8-core SBC that's been around for a while now. But how good is it? Find out in this video. Hi, this video is sponsored by JLC PCB, who make all my PCBs. They can make PCBs with castellated edges, BGAs, and track widths down to 0.2mm. If you're looking for some top quality, fast turnaround PCBs at a very low price, then I'd consider checking them out. They're currently offering 10 PCBs for only $2, and if you're a first time customer, you can get a voucher for $20 off your first shipping. So go and check them out. The ODROID XU4 first hit the shelves in May 2015, and it's only seen a couple of minor hardware changes since. So the design is pretty decent, and a large fan base has developed behind it. I ordered the XU4Q, which is exactly the same as the XU4, but with a fanless heatsink, and of course a slower CPU clock. So what does this little baby give us? Starting from the right and working clockwise. RTC battery header, console UART, dual USB 3.0 ports, power button, 30-pin GPIO header with the usual complement of GPIOs, an additional 12-pin GPIO header. The GPIOs on this board have issues, which we'll see later. eMMC or SD boot selector, HDMI capable of 1080p at 60 frames per second, micro SD slot, status and power LEDs, 5V 4A DC jack, USB 2.0 port, PWM controlled fan, and gigabit Ethernet. Removing the heatsink shows up a pretty well designed board. We have an RTL 8153, which is a USB 3.0 to gigabit Ethernet bridge, USB ESD protection ICs, a USB hub using the GL3521 IC, 512 kilobit SPI NOR flash, a nice juicy PMIC, and the octa-core Samsung Exynos using the big. LITTLE architecture, with 4 cores running at 2 GHz and the other 4 at 1.4 GHz. Then there's the HDMI ESD protection, power good signal circuitry, and current limiting switches for the USB ports. On the flip side, we have eMMC module header and a bunch of passives and protection ICs. The amount of vias on this board is crazy. To reduce EMI emission, they've placed a ground plane on the top and bottom. The ground plane is one of the most important layers, and this type of setup avoids ground loops being formed. So all in all, this is a pretty well designed board, with lots of ESD protection, adequate grounding, and a crazy amount of control over voltage levels. In terms of size, it's roughly that of the Raspberry Pi, just slightly bigger. On the documentation side, it's one of the best documented SBCs around. They have info on RAM and CPU overclocking, booting and bootloader recovery, schematics and general hardware info. Nice. For my tests, I used the best Linux distro for this SBC, which is Armbian. From power on to network activity, I saw around 22 seconds, with the desktop coming in 3 seconds later. Not bad. And of course, running the latest kernel, nice to see, which means that everything is there. CPU frequency control, and remember all those PMICs I mentioned? Yep, you have access to pretty much all voltage levels on the board. Throughout all my testing, I kept track of the current CPU loading and temperature, and also logged current and voltage levels. So far, the board looks pretty good. However, when we get onto GPIO testing, things change slightly. First of all, the GPIO header pins aren't a standard 2.54mm pitch, but 2mm instead. This means that standard jumper cables will be too big to use. Secondly, the GPIOs use a 1.8V logic level, so you're going to have to use logic level converters. This isn't quite straightforward, as a lot of logic level converter ICs have trouble with fast signals, such as SPI. If you want to be able to hack around with the GPIOs on this board, then I suggest also buying the Shifter Shield PCB from Hardkernel, as this not only provides logic level converters, but pushes out a standard 40-pin GPIO Pi header. The Samsung SoC has a huge amount of GPIOs, far more than are pushed out on this SBC. However, hardkernel have provided a wiring Pi compatible API, which you can fetch from GitHub and build an example. See, blinky blinky. We also have I2C and SPI available. Since I didn't order the shifter shield, I had to wire up my own logic level converter. I used an MCP9808 temperature sensor to test out I2C, and just used a handy heat source to change the temperature. Yep, everything just works. Moving on to the Phoronix tests, I initially installed the ARMSOC Exynos graphics driver from the Ubuntu repos, but I soon discovered that this wasn't the best idea. On the X11 performance tests, I was initially getting between 1/20th and 1/40th the performance of the Tinkerboard, which is not really what it should be doing. Doing some googling around, apparently this is a common error, so I removed it and the results were more in line with my expectation. However, this is just 2D graphics, and 3D graphics was reporting software rendering, so a lot of the 3D graphics results were skewed. So after running tests over 4 days, what results did I see? GL Mark II results were to be expected, as I wasn't using any 3D graphics driver. RAM speed benchmarks generally sat amongst all the other 64-bit boards, but being regularly beaten by the ODROID X86, Upboard and Tinkerboard, except for the floating point results. Stream tests were abysmally bad for some reason, but when it came to cache bench, it was top of the game again. So a real mixed bag of results. Moving on to networking, iPerf showed up a pretty abysmal 570 megabits per second, and local loopback was bleh. And yes, that is a technical term. Actually, it wasn't too bad, not as bleh as the gigabit Ethernet tests. The stress NG tests showed it to be leaps and bounds better than the ROC64, but I couldn't find any other recent test results on openbenchmarking.org, including other SBCs. Moving on to some computation benchmarks, I saw the XU4 screaming ahead of everything else, due mainly to its 8 cores. It was unbeaten on all the tests until it came to the small PT test, where it was just nudged by the ODROID X86 and Upboard. Moving on to the compression and encryption benchmarks, it was just nudging the ODROID X86 in the BORC benchmark, but lagging behind in the parallel BZIP2 benchmark, which was pretty surprising. So once again, a bit of a mixed bag. When it comes to compiling, the XU4 came out on top once again, due to its 8 cores. And the Go benchmark was, well, at least screaming ahead of the ROC64. And PHP was leaving everyone else in the dust. Moving on to power consumption, I saw the initial boot and idle test coming up with a 3 amp peak current draw, with an idle of 786 milliamps. That's one of the largest current draws I've seen on all the SPs I've tested so far. During testing, the average was hitting 2.4 amps with a max of 3.2 amps. That's also the highest average current draw compared to other SBCs. Moving over to the temperature stats, the initial boot and idle tests saw an average of 52 degrees Celsius with a maximum of 71 degrees Celsius. This was with an ambient room temperature of 20 degrees Celsius. While during testing, the average jumped to 66 degrees with a max of 83 degrees. Overall, the temperatures were pretty stable, with some tests like the small PT, OpenCL and kernel compilation raising the core temperature to the max consistently. So what do I think of the ODROID XU4? If you compare it to the other 8-core SBCs, it definitely comes out on top. It is one of the more mature SBCs out there, able to run the mainline Linux kernel. Documentation and support is very well entrenched, with a big fan base behind it. So if you get stuck, there'll be plenty of people to help you out. I was surprised at how well the CPU kept its temperature under control, given that on other SBCs, some of the tests I did made the CPU throttle. However, there's a couple of downsides to this board. The binary blobs that are required for graphics, but that can be said for a lot of other SBCs as well. There's also the logic level issue, and networking isn't that great compared to other SBCs with gigabit Ethernet. Also, the lack of Wi-Fi might turn some people off. However, if you want a decent 8-core SBC that performs well with a bucket load of support, then get an XU4. So is there anything else? Nothing? Okay. Thanks for watching, and see you next week.
subliminal advertising.